Hello dear students, today I will discuss about events, probability chapter. Just we have already discussed in the previous class about sample space, outcomes, random experiment. So now I will discuss about events. What is event? There are many terms for finding probability, axiomatic approach of probability. So events about its type also. What is event? Our discussion is just related to set operation. Just we know union of sets, intersection of sets, complement of set, difference of sets. So here first of all we are trying to understand what is event. Clear? So up to now we have already discussed about random experiment. Whenever we do some activity or random experiment. Now what is random experiment? We know. Okay. After doing some experiment, we are getting some result, that is called outcomes, possible outcomes. So random experiments having outcomes, okay, and set of outcomes, what? Sample space, all outcomes, that is sample space. Okay, now what is event? How can you define event? Okay, here sample space what? Containing all the possible outcomes of an experiment. Okay, all the and sample space are written as like this. S sample space. Outcomes. All outcomes are listed as element of set. That is called sample space. What X? X is outcome of random experiment. Okay. All the points of the set, all the elements of the sample space, that is outcomes. Suppose elements are what? Means what? Sample space containing all the outcomes of experiment. Suppose it have outcomes S1, S2, S3, S4, S5, S6, S7, S8, S9, S10. Suppose for example 10 outcomes of an experiment are possible. All the outcomes are written in sample space. These are the outcomes of an experiment. Okay, these are the sample. These points are called sample points. sample points, and also each outcome is called elementary event, also called elementary event. These are the possible outcomes. Now, event, how can we define event? Generally, sample space serves as, in a set theory, universal set, because sample space is what? Set. If we say like this, then for all the questions, all the problems related to probability, sample space behaves like universal set. Sample space is universal set because all the outcomes are here, and events. What is event? Suppose we are defining an event. So event means, for example, if we toss two coins, then sample space will be what? H, 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 T, T, H, T, T. That is sample space. Tossing two coins gives sample space as this. Tossing, this is experiment. This is experiment. This is experiment. Tossing two coins gives sample space this. Now, event, we can define event getting exactly one tail or getting one tail, because here this, because tossing a coin, possible outcomes are what? How many outcomes are possible? 4. First, this is S1, this is S2, this is S3, this is S4. We can denote, if suppose here 10, but here S1, S2, S3, S4. 4 outcomes are possible. So 4 outcomes are having here. So now, if event, we define event. If event is defined as what? Event is defined as how? Exactly one head. Just say event getting exactly on head, because two coin tossed on two coin. First coin may show head. With this head, second coin can show head or tail. Similarly, first coin may show tail, second coin will show head or tail. So 4 outcomes. Here exactly one head having this and this. So 2 outcomes are favor to this event. 2 outcomes are favor to this event. Okay, if E will be what? S2, S3. That is what? 2 here. S2, S3. So just now we are writing like this. Okay. Event is equals to what? Is denoted by E, because exactly one head means what? HT and TH. 2 S2, S3. That is what? S2 and S3. E. Here sample space is what? S equals to S1, S2, S3, S4. This sample space. So elements of this set S1, S2, S3, S4, that is this all are possible outcomes, and event is what? Getting exactly one head correspond to here, that is this two. If we get this, our event has occurred. If we get this, our event has occurred. That means these two sample point favor to this event, that is S1, S2. So we can see that this is subset of S. Similarly, if we define event getting two head, F getting two head, that is what? HH. That is what? S1. F getting two head. So this is favor to the event. So S1. This is also a single element. This is also subset of this. If we define at least one head. At least one head. At least one head means maybe one head, two head. So at least one head, what? One head, two head. HH, HT, TH. This three. It is what? S1, S2, S3. Okay. So EF, this is event, suppose A is this. Here we see that this event is also, this set is also subset of this. Because S1, S2, S3 favor to this event. So that means what we say? That all the events related to this experiment, all the events related to this experiment are subset of sample space. Okay? So different type of events we can define, just like this, and we can say that some of the sample points, that is outcomes, will favor to that event. Maybe one sample point favor, maybe two sample point favor the event, maybe three sample point may favor the event, maybe all sample point favor the event. Okay, if we write getting either head or tail, means what? All S1, S2, S3, S4, either head or tail, that is all the sample point favor this event. So this is B. What is equals to S? Sample space. That is sample space. S is also subset of S. So we say that different type of events related to a experiment are what? Subset of sample space. Because sample space is what? Set of all the possible outcomes of the corresponding experiment. So here we can define event as what? Any subset of sample space is called an event. Event can contain one simple point, sample point. Sample point means what? Elements of sample space. That is sample space as a set. Those points are elements of sample space are called sample point. Also, elements are elementary events because one sample point is also maybe an event. So each sample point also define an elementary events. So each sample point of sample space is also elementary events or simple event we can say. Clear? So here all the subsets, any subset of sample space is called an event. Here we see that phi, we know from the set theory, phi is what? Is set having no element. Having no element. That is empty set. So phi is also subset of S, because the empty set is subset of all the set. So phi is also subset of sample space. But phi having no outcomes, no element, that is no outcomes. Okay? So this type of set may be there if we define event as getting more than 2 tails. So that will be not our outcomes. So there is no outcome. Shows more than 2 tails. That will be empty set. So empty set is subset of also S. So this empty set is also maybe an event. That is impossible event. Just like rolling a die, we are getting samples 1, 2, 3, 4, 5, 6, getting a number greater than 6. Nothing is there. So empty set is subset of the sample space. That is impossible event. Are all the elements sure events? Sure event means what? So all the sample space, this is sure event, because all the sample points, whenever we define events under an experiment, so all the sample points if we take, then any of the outcomes will come for the experiment. So sample space is sure. So here, what is our definition of event? And a subset of sample space is called an event. Okay? And occurrence of an event, occurrence of an event. Occurrence of an event, happening of an event. What? Happening or occurrence of an event. What is that? Happening or occurrence of an event. So here it can be understood by the discussion like this. Suppose for this sample space is what? HH, HT, TH, TT. Means tossing 2 coins. We are getting sample space like this. These are the sample point. 1, 2, 3, 4 points are there. All the points are called sample point. Possible outcomes, elementary events also, sample points, event. E, getting at least on tail. Suppose this is event. Getting at least one tail. At least one tail means 1 tail, 2 tail. Here maximum 2 tail may be possible. So this E is what? 1 tail, 1 tail, 2 tail. HT, TH and TT. This is the event. Clear? Now, doing experiment, we are getting TH. First coin show tail and second coin show head. Clear? This outcome comes under this experiment. Then we can say that this event occurs. Also, if we get HT outcome. Also we say that event E has occurred because this belongs to this belongs to this. Also if we get TT as outcome, then we say also that event E has occurred. Either of these three outcomes we get, then we say that E has occurred. But for the outcome head, if we get this, head, both point shows head, then we say that E has not occurred because this is not favor to this event. Okay, these three are favor to this event. So if we get this outcome, then event E has not occurred. Okay, so for a experiment, if S omega is an outcome, if omega belongs to the event E, for a outcome omega of experiment, omega belongs to E, if omega belongs to E, then E has occurred. This is the occurrence meaning. If omega does not belongs to E, then E has not occurred. Clear? So this is the occurrence of event. Okay. Now types of events. Here types of events, just like impossible event and sure event. Impossible event is what? Empty set. That is because we know what is the definition of event? Subset of, any subset of sample space. Okay? Sample space and then what? Any subset of sample space is event. Okay? Any subset of sample space event. Clear? Now its type. Its type. What? Impossible event, that is 5. And that is improper subset. Improper subset we know from the set theory. Improper subset means phi is always subset of any set, and any set is subset of all times of itself. So they are here phi impossible event, and sample space is sure event. Just we have already discussed about it. Okay, phi means nothing element is there, and phi is always subset of sample space. So phi is having no element. That means there is no outcome which favor to the event. So impossible event. And sample space means sample space containing all the outcomes. So any of the outcomes we will get by doing experiment. So sample space is sure event. Any of the outcome we will get by doing experiment, and that outcome belongs to the sample space. So sample space is sure event. Okay. These are our basic definition. Now simple event. What is simple event? Just sample point are known as simple events. Events. Just now we know that event is what? Subset. Subset means what? Set. So if event contain, because what? Even what contain event? Event is contains sample points, outcomes, either 1, 2, 3, 4 or nothing. Nothing means impossible event. Okay, and one may contain 1, 2, 3, 4, 5. So if event contain only one outcome, sample point, only one sample point, then event is called simple event. That means what? If our sample space is S1, S2, S3, S4, S5, S6, suppose these are sample space containing 6 sample points. So single simple point having event means if is event and containing either S1 or S2 or S3 or S4 and etc. So single, only one sample point, then you will call simple event, or also called elementary event. Elementary event. What is elementary event? Elementary event means each outcomes are itself elementary events. Sample points are called elementary events also, simple events. Okay. And compound event. What is compound event? If event contains more than one, if event contains more than one sample point, more than one sample points, then event is called compound event. Compound event. Okay? Compound event. What is compound event? That is, event may contain S1, S2, or may contain S2, S5, S6. And these are sub events because these are all are subset of sample space. So containing more than one sample point called compound event. Okay? Just like under sample space, event is contained like HT, TH. Compound event. Only single sample point containing simple event. Okay? Now, algebra of event. So here we see that what is event? Event is any subset of sample space. 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 So generally we are denoting events by E, F, A, B, C, D, capital A, B, C, D. Sample space is denoted by S. Okay. So here algebra of events. So here we see that events are what? Subset. Subset means set. Simple is event is what? Set. So set theory. In the set theory we know there are different ways for combining two sets. There are union, intersection, complement, difference. These are the operation with set, that is combining of two sets. So here events means sets. So events, that operation can also be applied with events. So here one by one we can understand the operation with events, that is ways of how can we combine two events, just like in set theory. So complementary events. First of all, complementary, complementary set. So here types of events, and then algebra of events. algebra of events. Just like as set theoretical. Just like set theoretical operation. Set theoretical, just like set theoretical operation. First, complementary events. Complementary events. Complementary events. We know set, if A is a set, then it's A dash is equals to, here all the events are subset of sample space. So sample space we have like universal set. So if A is an event, that is E is an event, then complement of this, E is set, complement of this is equals to what? S, universal set, minus E. That is S A dash equals to what? U minus A. Just we are writing like this. Accept A, all the elements of U. That is, here all the sample points. Accept sample point in E. This is the complementary events. For example, here just take experiment tossing 3 coins. Okay, tossing 3 coins. Okay, tossing 3 coins. Then our sample space is what? Tossing 3 coins or tossing 2 coins. Just understand. For understand, right? Suppose tossing 2 coins. 2 coins. So experiment is this. Sample space. Just for an experiment, you have to write sample space first. So sample space S equals to what? Tossing 2 coins. That is head tail, tail head, tail tail. This is sample space for this experiment. Tossing 2 coins. Okay. Now, event, complementary events. Okay. So event, take an event E getting at least one head. At least one head means 1 head, 2 head, maybe. So E equals to what? These 3 outcomes favor to the event. At least 1 head means 1 head, 2 head, 1 head, 1 head, 2 head. Now for the outcomes TT, we see that event E has not occurred. And for complement of this, complementary event, is E dash. E dash means what? Accept these outcomes. What are the outcomes in sample space? This is equals to what? Sample space minus E. That is, we can write that is for this outcome E is not occurred. E has not occurred. Okay. If we are taking event as getting 2 head, then F event will be what? 2 head means this. This favorable outcome. This will be the event. Then f dash equal to what? S minus f. S minus f means we see that these three outcomes are not favorable for this event. So its complement will be remaining three. What? HT, TH and TT. Because for this outcome, for these three outcomes, event has not occurred. So complementary events. This. Clear? As a set theory. And finally we can write what? Because we know event containing sample point. So we can write how? Complementary events. If E is event, then E dash equals to what? Outcome belongs to sample space such that does not belongs to E. Okay? Omega belongs to S, that means what? Outcome belongs to the sample space. But omega does not belongs to the event E. That is what? S minus W. We can write, S minus D. It can be written as S minus E. Second event is, now event A or B, A and B, A but not B. Okay, we can write event A or B. We can write also A or B, A, B, C, capital letter for event. A is an event, B is an event. Event A or B. A or B, we know A or B, we can write also A union B. A or B means what? This A union B, event A or B, can write A union B. We know from the set theoretical. Here omega belongs to sample space such that omega belongs to A or omega belongs to B. Omega belongs to A or omega belongs to B. Just like set theory, nothing more. Okay. Similarly, 3. Event A and B. Event A and B means what? A intersection B. And this is, we know what? Omega such that omega belongs to sample, outcomes belongs to sample space, omega belongs to A and omega belongs to B. Just like set theory. Here AB are events. AB are events means having sample points, some sample points. So this is can be written A and B. And 4. Event A but not B. Event A but not B. Event A but not B. Here not means this complementary event. It is also right, not E. Not E. Not E. Event not E. Not A, not B, that is A dash. A dash means what? Not A. Not A means A has not occurred. Okay? So here A but not B means you can write A minus B. Okay? So sample points in A, containing A but not in B. Set. This is also event. Event is what? Set. So even this event is what? sample points in the set A but not in the set B. So A minus B. It can be also written as A intersection B dash, Okay, A intersection B dash. A minus B equal to A intersection B dash. So remember this type of writing, A or B event, either A or B event happening, A and B both happenings, and A happening A but not B, A minus B, A intersection B dash. Complementary means E dash, not E happening. Complementary means E not happening, then not E, you can also write. So this type of discussion are important for solving questions related to probability. Events can, how can we say, A union B means what? Either event A occur or event B occur. A and B means both happening. Event A and B, both happening. Maybe it contains some sample point, it contains some sample point. And intersection means both containing that outcomes. Containing outcomes but not containing in B. So these are the algebra of events. Okay. So just taking an example, suppose we are doing an experiment, rolling a die. Then how can we write the event? So here we want to see. So rolling a die having sample space 1, 2, 3, 4, 5, 6. Experiment, rolling a die, sample space. Will contain 1, 2, 3, 4, 5, 6. 6 numbers may we get. So this sample space will be this. Now defining events A. 2 events we are defining here. What? Getting prime number and numberless odd numbers. Getting prime number. Getting prime number. So what will be the value of a rolling die and getting prime number? What is prime number in this? The sample space is this. So 2, 3, 5 are prime number. So you can write event 2, 3, 5. This is subset of sample space event. And another event is B. Getting odd number. So B will be what? 1, 3, 5. They are the odd number. These outcomes are favorable to the event B. So 1, 3, 5. Now, just we are trying to find value one by one. First, what? A or B? Event A or B. That is what? A union B. So we can find A union B from here. What? 1, 2, 3, 5. 1, 2, 3, 5. Either A happening or B happening. A union B. This event A or B. Okay? A or B event. Similarly, second event, what? A and B. Event A and B. Means what? A intersection B. and B means intersection B. So intersection of these two, what? 3, 5. So 3, 5. Okay, now A but not B. Third, if we want to find A but not B, means what? A minus B means what? Outcomes in A but not in B. In A but not in B. In A 2, not in B. So this is 2. 2. This is event 2. Single point 2. And not A 4. Not A. This is event. Not A event means what? A dash. A dash. A dash means what? S minus A. Means what? S minus A. Means in sample space but not in A. Means 2, 3, 5. So 1, 4, 6. So 1, 4, 6. This is also subset of sample space. So this is event. So this type of operation can be used for finding new event. That is event A or B, event A and B, event A but not B, event not A. Okay. So remember this type of discussion about event. Here, two things are more: mutually exclusive events and exhaustive events. Okay. Just we are trying to understand what events are known as mutually exclusive events and what are known as exhaustive events. Very, very important point is mutually exclusive events and exhaustive events. Okay. Here, see. Mutually exclusive events and exhaustive events. Exhaustive events. Okay. Mutually exclusive events means what? Very, very important point is this. Mutually exclusive events means whenever occurrence of events, suppose two events are there, A and B. One event A and another event is B. Occurrence of the event A excludes the occurrence of the event B. Means prevents, you can say. If A occurred, then B cannot occur. That is, we can also say that A and B are not simultaneous, cannot be simultaneously occurred. If two events cannot be occurred simultaneously, that is, occurrence of event A prevents the occurrence of event B. Occurrence of the events B excludes the occurrence of event A. Then we say that two events are mutually exclusive events. What are the mutually exclusive events? If two events are not simultaneously occurred. Clear? That is, should be 5. Simultaneously cannot be occurred. That means intersection is 5. So in set theoretical notation, if this, then A and B are mutually exclusive events. Clear? Mutually exclusive events. A intersection B equals to phi. In set theoretical notation, you can say that disjoint set. What? Disjoint. Disjoint sets. If E and F are disjoint, then intersection equals to what? Phi. And not phi, not disjoint. Not disjoint, not mutually exclusive events. Okay? Here we can see that rolling a die, sample space is what? 1, 2, 3, 4, 5 and 6. Event A getting even number, B getting odd number, what? Event 2, 4, 6 getting odd number 1, 3, 5. A intersection B equals to what? 5. Mutually exclusive implies events A and B are mutually exclusive events. Clear? So mutually exclusive events are this. Now exhaustive events. So here just take example of exhaustive events. Exhaustive events means if E1, E2, E3, suppose En, if these are n events of an experiment, or n events of an experiment such that E1 union E2 union E3 union of all these union En, that is equals to S. E1 union E2 union E3 union En is equals to S, and necessarily all the events occurs whenever the experiment, if E1, E2, E3, En are n events of an experiment such that union of all these are equals to S sample space, and all these then means these are events related to an experiment, so that union of these events is equals to sample space, okay, equal to sample space this, then E1, E2, En are called exhaustive events if at least one of these events these are n events of experiment and union of experiment is equals to S. Then these events are called exhaustive events. If at least one of these events, necessarily occurred, or at least one of these event, such that this condition is also, and at least one of these events, necessarily occurred whenever this experiment is performed. Whenever the experiment is performed, then at least one of these events must be occurred. Okay, necessarily occurred. So union of these events is equals to S, and at least one of the events must occur whenever experiment is done. Okay, so then we say that these events are exhaustive events. For example, suppose rolling a die, sample space what? 1, 2, 3, 4, 5, 6. Events A. Getting number less than 4. B. Getting number greater than 2 but less than 5, and C. Getting number greater than 4. Suppose we are considering like this event. So getting number less than 4 means what? Less than 4. 1, 2, 3. 1, 2, 3. Less than 4 means this. And getting number greater than 2. Less than 5. Greater than 2, less than 5 is 3, 4. This is 3, 4. 3, 4. And C. Getting number greater than 4 means 5, 6. So we are having 3 events A, B, C. Now here we see that A union B union C. There are 3 events. Just union this. 1, 2, 3. Union what? 3, 4. Union what? 5, 6. So here we see that 1, 2, 3, 4, 5, 6. That is sample space. That means what? This, and at least one of this event occurs. At least one of these events occur whenever we throw die, then we can get 1, 2, 3 or 3, 4 or 5, 6. One of the event will be occur, at least one of the event will be occur. If we get 5, then C occur. If we get 3, then B occur, and A at least 1. So at least one of the event has occurred whenever rolling a die, and union of these 3 is equals to S. That is, therefore A, B, C are exhaustive exhaustive events. Exhaustive events. Clear? And in this definition, if mutually exclusive and exhaustive events E1, E2, E3, En are mutually and mutually exclusive and exhaustive events. If EI intersection EJ is equals to phi for I is not equals to J, and EI union of this, just we can write like this, I equal to 1 to n EI is equals to S. This two, because this is exhaustive. For union of this, all the events is equals to S, and also pairwise disjoint. Pairwise disjoint. With disjoint, then mutually exclusive. Union is equal to S, then exhaustive. So the events, these are mutually exclusive and exhaustive events if first condition is this and second is this. Means both. Union of this means what? Union. Greater union means what? E1 union, E2 union, E3 union, and so on. Union En equals to S. This means, or this. This is for exhaustive and this is for mutually exclusive. So, for showing events are mutually exclusive, just we see that their intersection is phi or not. If phi, then mutually exclusive. If all the union of all the events is equals to S and one of the events occurred, then we can say exhaustive. So this is exhaustive, this is mutually exclusive. So if these two conditions are satisfied, then we can say that mutually exclusive and exhaustive events. Okay? So these are the basic facts about events, types of events, algebra of events, and what are mutually exclusive events, exhaustive events. So just write all the definition in your copy with some examples and see examples from book and write all the definition of these events. Okay, we will use this definition and this idea for solving exercise 16.2 in next class. Okay, and just write all the definition with examples. Okay, so very important. Maybe ask also in question exam. So write it and send me for your attendance. Okay.